Hello. Today we're going to discuss about some of the assignments problem that about SVM assignments that has been given as our case study. So first of all, I need to briefly explain the context of the assignment that has been given and the data sets. So it was a classic problem where we need to have design patterns recognition in the form of handwritten digit recognitions, which are there are so many images which have a digit submitted by user via scanner or tablet or any digital devices. So the goal of this assignment is to develop a model using a support vector machines SVM, which would directly should correctly classify the handwritten digits made on the pixel values given as a features. And for this problem we have used MNIST datasets, which is large database of handwritten digits where we have pixel values of each digits along with its level. Now there are other methods followed with the very common questions that how these images are being converted to the features. So this is a very tactical questions which we dealt on. So while in our database structure in our analysis for this assignment, we initially have a database of MST and ST, train and test database. Both these database contains a large number of values, so we have to minimize or segregate those values using some 2000 values. So then we have to model those and we have to train those, and we have to analyze using the train database and the test database. Now moving on to some other following questions, where now briefly explains how SVM works. Now this SVM is basically a support vector machines, and it works very well and with clear margin of separations, and it is a high dimensional spaces, and it is effective in cases where number of dimensions are greater than the number of samples. So it uses a subsets of training points in the decision functions called support vectors, and so it is a memory efficient. Now moving on to the next questions, what is margin and what is maximum margin classifiers? Margin classifiers in machine learning, margin classifiers is a classifier which is able to give an associate distance from the decision boundary for each examples. Now another examples which we have, there is another question lined up where I should follow that what are the advantages of using SVM for this task as compared to other classification models as linear regressions. SVM is basically a linear regressions with the L2 regularizations, and it is slightly different loss functions. That is, SVM uses hinge loss while logistics uses log loss. I treat this method as essentially, like for example, essentially equivalent that one should easily get probabilities from SVM through the flat scaling. Now I find logistic regressions also slightly more appealing, theoretically given the maximum likelihood formulations, that is, assume response variables are like Bernoulli's theorems, where log n of the probability is linear in the explanatory variables, and like, but in practice I found that SVM gives a slightly better performance, but very slight over logistic regressions. Now moving on to the next questions, what are hyperparameters of SVM? The SVM another sets of parameters called hyperparameters, and soft margins, constant C, and any parameters. The kernel functions may depend on the width of the Gaussian kernel or the degree of vulnerable kernel. So kernel parameters also have a significant effect on the decision boundary. Now this are the basic line of questions which we followed using analysis of this SVM assignments. Thank you.